Metal forging is like giving metal a workout. We heat it up, then use hammers or presses to shape it. It's an old process but still important today. Visit us at www.agstech.net, think tools, engine parts, and even some jewelry. Forging makes metal stronger and tougher. It's like how exercise builds muscle. The process aligns the metal's grain, making it less likely to break under pressure. Forging can be done by hand, but most of the time, big machines do the work. These machines can handle huge pieces of metal, shaping them with incredible precision. There are a few ways to forge metal. Hot forging is the most common. We heat the metal until it's soft and glowing, then shape it. Cold forging is done at room temperature. It's good for making smaller parts with tight tolerances, but it takes more force. Open die forging uses flat or simple-shaped dies. The metal spreads out as it's hammered, so it's often used for basic shapes. Closed die forging uses two dies with a specific cavity. The hot metal is squeezed into the cavity, taking on the exact shape. There are many different forging techniques, each with its own purpose. Impression die forging. This is like making a metal cookie. We press hot metal into a die to create a raised design. Flashless forging. This technique is designed to minimize waste. The metal fills the entire die cavity, leaving no excess material. Cogging. This involves repeatedly hammering a bar of metal to reduce its thickness and increase its length. Fullering. This is like cogging, but we use rounded dies to create grooves or depressions in the metal. Edging. We use dies to shape the edges of a workpiece, often to create a desired profile or bevel. Precision forging. This requires specialized equipment and tight tolerances to create complex, near-net-shaped parts. Near-net-shape forging. This aims to produce parts as close to the final shape as possible, reducing the need for machining. Heading. We use pressure to form the head of a bolt, screw, or other fastener. Swagging. This involves reducing the diameter of a rod or tube by hammering it between two dies. Upset forging. This increases the diameter of a workpiece by compressing its length. Metal hobbing. We use a hardened tool to create gears and splines on a workpiece. Press and roll forging. This combines pressing and rolling to create long, straight parts with consistent cross-sections. Radial forging. This technique uses multiple hammers to shape a workpiece from the outside in. Orbital forging. This uses a rotating die to forge a workpiece, creating a seamless ring or tube. Ring rolling. We use rollers to shape a thick ring of metal, often used for bearings or gears. Isothermal forging. This involves heating both the workpiece and the dies to the same temperature, allowing for the forging of difficult-to-work materials. Forged parts are known for their strength and durability. They can handle a lot of stress and strain, making them ideal for demanding applications. Another benefit is that forging can create complex shapes that would be difficult or impossible to machine. Think about the intricate details on a wrench or the curves of a crankshaft. However, forging can be expensive, especially for small production runs. The dies used in the process can be costly to manufacture. Forging also has limitations in terms of the shapes it can create. You can't forge a hollow part, for example, without additional steps. Overall, forging is a valuable manufacturing process with a long history and a bright future. If you want to learn more about forging and the services offered by AGS-TECH, visit www.agstech.net.